All right, so I'm going to share screen just for a second here and just show you real quick. Okay, so everyone online can definitely hear me, okay? Yeah, okay, good, good, good. It might be a little bit loud actually, so let me know if it turns out to be that way. Okay, so if we're looking at our modules on Canvas, and we look at oh yeah, here it is, recording down here. All right, so here's the recording module, and there's all kinds of stuff that we'll talk about at a later date. But just real quick, for those of you who want to like go ahead and get started on it, like if you own your own microphone already and you have some time this weekend, I'm just telling you about it because I know the long weekend's coming up, and so I thought maybe you have some extra time to get started. And so, not that it takes forever, but it'll take a few hours. Okay. And so this is what it looks like. So basically, the main thing is you're going to make 10 field recordings, right? And so what this means is like just like recordings of literally any sound that's interesting to you. So this is not just like making high quality recordings of instruments and things like that. This is just literally any sound that you enjoy hearing or you think is an interesting sound, right? So you're going to make 10 of those. And then you're going to make 2 additional ones that you maybe don't like so well, or maybe they're the ones you like the best, whatever, but 2 additional ones on top of those 10 that you're going to share with the rest of the class. And so that'll be like, I don't know, whatever you call it, Creative Commons for our class, okay? And so that we'll be able to use those in projects later on. So we'll have like a big bank of sounds, okay? And so like the main point of this is to make good quality recordings, and just to get some practice with that. And so before I forget, those of you who are like all the way online only, like not in Houston, just like hang around for a minute after we're done with class if you don't have to go anywhere, and I'm gonna like ask you, just like we'll discuss a game plan for you getting a microphone if you don't already have one that we've discussed, okay? But yeah, okay. So but anyway, yeah. So those of you who want to get started, there's just a couple things. So there's no there's no time limit on like how long the recording should be. It doesn't have to be short, doesn't have to be long. It's just like whatever the sound is. Like however long the song, however long the sound lasts to you, that's how long your little recording should be. Yeah, so anywhere from like 2 seconds to like a minute, right? That's probably a good range for your sounds, okay? And get like the main thing that will make me upset about this assignment is not actually the bad quality, but like if you get like 10 recordings of almost the same thing, that was like the only thing that would make me like irritated mildly. And then I would just say, hey, you should do it again. Okay, that would be it. But yeah, the variety is like a big key thing here. So I want you to try to get some things like outdoor, try to get some things, small sounds inside, try to get, yeah, right? So don't record anything, don't like record any samples from YouTube or anything like that. This is something you want to do with your microphone, obviously. Okay. 2 big things just for the quality. Make sure you're not in a noisy room. Like if you can hear it with your ears, it's going to be in the recording times 10, okay? All right, so try to get in like a quiet space. Obviously, if you're doing an outdoor recording, that's not going to be something that you're listening for. If it's windy and you can put like, if you have like a microphone cover that you can put on it, that would be good too. Sample rate, use either 44 or 100 if you can figure out how to change that, and we'll talk about it further, but like I'm just giving you the assignment here. And then try to use, if you can, if your mic allows it, try to use 24-bit depth. All right, and we'll talk about what those things mean. We talked about sample rate a little bit already, and so you have an idea of like what that means. But try to figure out how your microphone works. See if you can change the settings to get that to work. And those of you who are here today, if you're going to check on a microphone from Rim Labs, I can let 3 of you do it, and I'll show you how to use it real quick too. Okay. All right, so that's that. Don't feel like you need to start on that right away. I'll go over this assignment again next week. But I just thought, yeah, I thought I would like talk about it before the long weekend, so if you're wanting to get started on it, if you have some time. Golden. Okay, so there's that. All right, we're gonna probably have to test some things before I actually get started talking about the important stuff. But one thing, if you want to follow along today on Canvas, dup, 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 where is it? It's always under modules, always under modules. And oh yeah, so slides for today is analog audio. And believe it or not, that's our subject for today, is analog audio, because I have beside me a analog synthesizer, like a very retro one, probably older than me. I don't know how old it is, but it might be older than me. Any guesses to how old I am? No, nobody's brave enough. Okay. Okay, younger than your parents. Just know that. Okay, so let's. I'm gonna flip this on. I'm gonna set up a camera here with my Zoom on, and so it'll take me a few minutes. So, because I want you guys to be able to see online what I'm doing, and then you guys in here should be able to see what I'm doing on the screen if I set it up properly. So I'm gonna turn up the lights back here a little bit, okay. And I'm gonna jostle around a little bit. So y'all online, I'm gonna mute just for a minute. Okay, and so cool. And I'll test the audio as we come along. Just in case, I'm gonna turn this down when I turn this on for you guys. Okay, cool. Okay, cool. So this is an analog synthesizer. Now that I'm set up, and you should, whenever I activate it, you should start hearing sound in both places. All right, cool. And so yeah, the word analog means that it basically means that the voltage signal through the synthesizer here is going to be analogous to the physical sound waveform in real life. Okay. Yeah, so that's where the word analog comes from. And basically, this is I like to use this because it's like a really good like pedagogical tool, actually, for like starting out for you noobs. Okay, and so we're just going to start with the simplest like possible thing, and we're going to like look at what it looks like and all that kind of stuff. But yeah, basic, and then we're just going to start to play with it a little bit. And then if I have time, we'll take a closer look at some other things. But I'll try to get us set up and doing some interesting things, hopefully musically today, which we've not really created anything yet. So let's get started. Okay, cool. So first thing I'll do, you can see online a little bit if I move it a little bit closer. Right here, this box right here. So there's different modules on this thing, and you can sort of like pick and choose what you want in your synthesizer. Right, so it's not just like a set thing. It didn't just come in this like big box like this. You kind of just pick what you want. There you go. Okay. All right, so here, this module right here is this is an oscillator, okay? And so this is gonna create a signal for us. And then we're gonna wanna send that signal to our speaker, okay? And so up here we can pick what frequency it is. And there's other stuff here we'll talk about later, but here's where the output is, okay, down here. And so we have several options. Some of them you might recognize already. So sine, you all know what a sine wave is. You all have heard a sawtooth wave so far. And we'll talk about what the others mean. Okay, but sine wave is just our simplest one. So let's see if we can get sound first. So this is where the output is. So I'm going to take it from here over to the output over here. If y'all can see, I don't know what I need to do to make it better. If y'all online are talking to me, I hope I can hear you. Okay, hit me up in the chat if you can't hear me, or if I can't hear you and you're talking to me. Okay, and cool. So right here is where we put the, yeah, so this is the output. It says input, but that's the input to the output, if that makes sense. Okay, and so that is going to send it to the speaker. So this is sending it to the speakers now. Okay, and so we're going to turn it up, and we're going to see if we can hear it in everywhere. Yeah, so it's probably really soft, and it's also, it's just very soft. Oh, I didn't have those speakers on at all. That's why. Okay, I'm going to turn my mic down because I'm probably going to feed back here in a second. Okay, cool. And I'll try to adjust the volume for you all online so that you can still hear me over the synthesizer. And then I'll probably just have to turn things down or whatever, but there you go. Okay. Yeah, it's very hard to get this balance right for everyone, but okay. So hopefully y'all can hear. A little soft, but you can hear. Yeah, it's a really soft sound right now anyway. Okay, so I'm going to turn it up. All right, and so you see here, right up here I can adjust the frequency, right? So this is going to be, right, if you can hear that, yeah. Okay, yeah, it's going to be soft for now. And then right here, this knob just changes the octaves. I don't know if you can see it, but it says 32 feet, 16 feet, 18, 8 feet, 4 feet, 2 feet. That's a reference to like pipe organ lengths. Okay, cool. So that's boring. So let's do something more interesting. Well, let's check out the other oscillators first. Okay, so here's a triangle wave, or let's hear a saw wave. This will be a little bit louder. Okay. Okay, so and y'all online can hear me okay? Over the synthesizer for the most part? Yes? Okay, good, good. Nice, nice. Okay, so there's our saw wave. And remember, this is the one with like all harmonics, right? Okay. And okay, so listen to a triangle wave. This one has all of the odd harmonics, okay? And so this is like, you can tell that it's a little bit brighter than just the sine wave, but it has like more partial or less partials than the sawtooth wave, right? So this is like all of the odd partials only, right? Okay, and then the similar to the triangle is the square wave. On the thing here, it's called pulse. And so that's, yeah, and so that has like the odd parcels also, and we'll talk about the difference between those two, but yeah. Okay, cool. So there's really basic oscillators. So let's do something more interesting. So what the main thing, my main goal today is to teach you about filters a little bit. And so, and that's where we'll get our most interesting sounds, actually. Okay, and so what we can do is instead of just routing, if you can see, you can see. And so I've got this routed directly to the speakers, but that's not very interesting. So yeah, and so what we can do instead is route it to another place and then route that to the speakers, okay? So what we're gonna do is we're gonna route it to this module over here. And this is, yeah, this is our filter over here, this whole module here, okay? And so what we're gonna do instead, we're gonna send it to, oh, right here, the input. That's where you want to put it. Okay. So that's our next step. Everyone in here okay? Are y'all learning or no? Yeah. Okay. Yeah. Okay. So next thing, so I'm going to take that, and we're going to go back to the sawtooth wave for reasons that will become apparent. And so what we're going to do here, and I'll try to show you a picture of what the sound looks like here in a minute. But basically what the filter does is it filters out certain frequencies, right? And so we can control like the timbre of our sound by using the filter, right? So remember the timbre is the relationship between the upper partials of the sound. And so what we're going to do, let's start with low pass. That's the easiest one to understand probably, okay? And so you can see over here, let me zoom in for you all people online. And by zoom in, I just mean move the camera to where you can see. Okay, and so you can see this a little bit better now. And so right here, you have 4 options for your filters. And so it gets pretty obvious what the word filter means, right? So it's just going to filter out some of the sound. And again, so we have 4 options. So high pass, band pass, notch, and low pass. And there are other options, but these are like the main 4 that you'll use for the most part. Okay, and so and that's all we have for today. So that's what you get. And so low pass does exactly what it says, right? So and this is going to allow for low pass. This is going to allow for low frequencies to pass through. Okay, does that make sense? And so And so let's just hear what it sounds like, and then you'll get an idea. It'll become pretty clear. Okay, so we can't hear anything right now probably, but up here at the top, yeah, you can see it. So up here at the top, it's in the shadow, but it says frequency. And so this is, we're going to change the frequency cutoff. This is called the cutoff, right? And so this is where the frequencies begin to cut off, okay? And so we can adjust that. And so since we're doing low pass and I'm not hearing anything, I'm going to need to raise the cutoff so I can hear more. Cool. So now you can hear it a little bit better, right? And so now, if I go all the way up, I'm going to turn this down, and I'll explain what that is in a second. But if I go all the way up, now I'm hearing my original sound, right? So this is just the pure sawtooth wave going through without any effect on it. And then as I cut off the top of the sound, by lowering this cutoff here, it's going to cut some off. All right, so we're cutting off the upper partials now. Cool. All right, so you get the idea. And so we'll talk about what this knob does in a second because that's important too. But let's try another one. So let's go to high pass now. All right, and so y'all can hear that. Let me know if it's too soft or too loud at any point. And so yeah, so I'm going to do, this does the opposite of the low pass, right? So this is going to allow high frequencies to go through. And so right now I've got the cutoff pretty high, and so now if I turn it down, you can start to hear the lower partials again, right? So this is doing the opposite. So now when I cut it off, it only allows the higher stuff to go through. Okay, until we get nothing. Right. Okay, nice, cool. So let's play around with those for a second, and let's just look at. I'm going to try to get a picture of what the sound actually looks like, so you can actually see it. Okay, and let me turn it down because that's probably annoying as hell, actually. And so yeah, let me check this out to make sure this is routed. And we're opening Reaper for the first time. Right? This is our main program, and I'm not going to really explain to you what's going on yet, but DVS C12, that's what we want. Okay. Okay, and so I should start to get sound in now. All right, cool. And let me show you now what's going on. You're fine. Okay, and so, oh, that's my sound coming in, but it should be mixed with the other sound too. Okay. All right, so y'all can see my screen, right? Cool, and so that's my voice that you're seeing there. Oh. Yes, okay, cool. And yeah, so this is my voice. So this is the spectrum. I can't really turn up my voice from that, but once I add the other sound in and just shut up, then you'll be able to see it. Okay, and so here is the synth. I'm going to turn on my mic. Cool. And so here you can literally see the partials. You can see my voice too, but whenever I'm quiet, you can see just the sine, or just the saw wave, right? And so that you can see the individual partials shining through. Can y'all see up there okay? Yeah? Okay, just let me know. And yeah, so you can see that shining through there. And then as I take the filter cutoff and I bring it up, we can see those sort of disappear. Okay, so I'm going to turn on my mic again. Cool. Okay, does everyone get the idea there? Okay. So that's what's going on in the filters. Do y'all see what's going on? Like, do you get like how it's working? Or let me know if you don't, I guess. Yeah. Yeah, so this is the high pass. So then when I raise the cutoff, then yeah, it cut off the lower end of it, right? Right. So high pass means that it allows the things above the cutoff frequency to come through, right? And then low pass means the things that are below the cutoff frequency goes through. Yeah. Okay. Cool. All right. So that's what's going on. So let's try the band pass now because that one's pretty interesting. And so you all online, I'll let you manage like what size all your screens are. So maybe there's a way you can see both the video of the synthesizer and me at the same time. Yeah, I don't know. Okay, and okay, so let's try the band pass. Right, so this one's good. Maybe we'll skip the notch for today, but oh, it's actually only 2, so we're doing pretty good. Okay, so bandpass does also what you might think it does, and so it's going to allow just a band of frequencies to go through. So when I change the frequency cutoff, then it's going to just like it's going to pick like a small range of frequencies and allow that through. Right. So it's basically, this is not what it is, but it's essentially just like if you can imagine a high pass and a low pass working together to cut off both of them, cut off both ends. Right. So let's look at what it looks like. Let's hear what it sounds like. Okay. Okay, cool. So does this one make sense? So yeah, this one just allowing a little bit to come through. You can see it all the way. You can see it coming through most of the time, but um, it like emphasizes a band of frequencies there. Right? So band pass. That's how that works. You notice to get it to like really be effective, I had to change this resonance knob here. And so what the resonance knob does, it works for all the filters, but it like boosts frequencies at the cutoff, right? And so with the band pass, that's obviously gonna like just like narrow the band and then like boost those frequencies even more. So let's look at that. Okay, and then with if we do like if we go back to low pass, then that will boost the frequencies at the cutoff too. Okay, so let's look at that. Okay, so I'll give you a break from that for a second because I know it can get annoying when you're just doing like one sound. Okay, cool. So any questions so far? Yeah, stop me anytime you need if you have questions. Anything? No. Okay. Cool. So this is making sense for everyone, I think. And so the reason I'm showing you this is not just to be like totally retro and show you how this thing works, but I also there's a virtual one that I asked you to maybe download for today to try it out. And so if we have time at the end of the day, I'll show you a little bit how it works. But that's the VCV rec, and this is a much cheaper version of the of the physical thing I have here. And so you can kind of play with it. It's free, and you can download more like modules to add to it or whatever. But this is like really good for actually like trying to understand how to make sounds, um, especially if you're the type of person that wants to like learn how to make your own like synthesizers or whatever to play little melodies or for your pop songs or whatever you want to do. Um, but it's also good if you just want to like kind of learn how sound works. Okay, so there's lots of benefits to just experimenting with that. If you and if you're like interested in the science of sound, it's like really good. Um, it's a good way to like experiment too. Okay, cool. Yeah, and so again, I'll show you this if we have time. Once I get through everything, but let's do a little more experimenting with this because this is just a lot of fun and it might be the only chance we get to do. this semester with this guy. So I'm just gonna get rid of the share screen. Go back to full screen, I think. Cool. Okay, so y'all can see this. And so let's just make something now. Let's do something interesting. I kind of have a plan of what I want to do, but it never turns out the way you want. It doesn't always turn out the way you want every time. And that's fine. That's like kind of the cool part about it. And so one other thing about this is like, like right now I'm trying to show you like a very specific way to control the sound and all that stuff. But most of the time what you want to do with these is actually just kind of like play with it and just like sort of mess around until you get a sound that's interesting to you. Because there's way more interesting things you can do than what we were doing just a second ago. I was just kind of trying to show you how filters work if you've never experienced that, assuming that you haven't. Okay, but we're gonna actually use our filters for the next part of what I want to do, and I'm gonna change it back over to bandpass. Right, so let's just review the signal flow here. What we got so far is we have the sawtooth wave coming out of here, right, and that's going into our filter and then out the filter, and I want to use the bandpass for now. Okay, and everyone online can hear me? Yeah, okay, cool. And so from here now, what I want to do is I'm going to use, let's test and see how this works first. Let me show this part's working. Okay, cool, so we have that going through. And so you can kind of hear it, actually, it's like isolating the individual overtones. We got bandpass on. And if I turn the resonance up, then we can get like a really bright sound. Let me change the fundamental, actually, so we can hear what that sounds like. All right, cool, so we can slide that around. Let's go a lower octave. And we're going to try to just like isolate the overtones. Oh yeah, that's pretty cool. All right, but yeah, let's just sweep through them real slow. Cool, cool. And so now imagine that instead of doing that with my hand, I could have something else control this frequency, okay? And so there's a way to do that, actually. So if you look right here closer to the filter, and once again, like this is analogous to how that program on that VCV rack that's like an emulator of a modular synth. This is going to work very similar, actually. Okay, so this is applicable to that. And so you see right here, there's this little thing that lines up to this. And so what this does is allows another signal to control the frequency cutoff of the filter. Okay, right? And so essentially, what's going to do is change this for me without me having to do it. Right? And so what we're going to try to get it to do is to do that in like a rhythmic way. Okay, cool. And so what we need to do then, let me turn this down. I know that's annoying when I leave that running. And so what we're going to do first, what should we do first? Well, let's do something simple first, okay? And so what we can do then is we can take another oscillator to control the cutoff of the filter, okay? And so like instead of me doing it by hand again, I'm going to let this other oscillator do it for me, okay? All right, so what we're going to do is we're just going to take, let's take the triangle wave. And instead of doing it in an audible frequency, right? Because remember, this is like if it's in a range that we can hear, it's going to be like what? Maybe like, I don't know. Let's just say 200 hertz or something, right? So it's going to be doing it 200 times per second. But if you see here, you can change the octave so low that it's actually below 20 hertz. Okay, can you see it? Yeah, probably not. Right here, if I change this octave knob here, you can get it down to the low. And this will be what we call a low frequency oscillator, okay? And you can see the light there blinking. That's how fast the frequency is, right? So if I go up into the audible range, then it's just solid. But then if I go LFO, low frequency oscillator, then it's like that's how fast the sine wave is, right? So we're not going to be able to hear this wave, but now we can use it as a control for our filter over here, right? So we're going to use it to control our filter cutoff. It's going to sound kind of cheesy right now, but that's fine. At least we know what's going on. Okay, cool. So why no sound? Because the volume's down. That's why. Oh yeah. Okay. Because everyone can hear that. Yeah. Let me check the chat. Okay, so that's kind of cheesy, but it's fine. And so now this knob right here controls how much this signal affects the cutoff. Okay, so well, yeah, and also I can change the cutoff still, right? So that still works, but this is like the center of like what's affected by this. Okay, that makes sense. Okay, cool. And then I'm gonna turn this resonance down a little bit too. And okay, and so then this knob here will control the effect of this, like how much this affects this. Okay, and so right now it's like a 0, and so it's not going to do much. But then if I turn it up more, then it's going to be, you're going to get that goofy noise. Or if I could bring it down to 0, then it's not going to do anything. Yeah. And the other way just does the same thing. Yeah, okay, awesome. And so then, of course, we can speed it up by changing the frequency of the low frequency oscillator over here. Yeah. Oh yeah. Okay. And then of course we can make it like a bass note too. Oh yeah. That's fat. Okay. Yeah. Okay. Anyway. All right. So there's that step. Any questions about what's going on there? All right. So maybe we're starting to see some of the uses or the power of this little setup here. Everyone good? Okay. Okay. Everyone know what's going on? Okay. Cool. All right. So let's take it a step further. What time is it? 11? Okay. Thanks. So let's go down to this little guy down here. I'm going to try to make you shorter, online people. Okay. And so down here is a little guy that says noise. Do you see that? If I hold it still, maybe you can. So you can see this guy here says noise. And so this little module here, this little box, just makes noise for us. And you can see down here there's a few options, white, pink, and then low frequency. Okay, and so yeah, so I've already got set up actually. I picked the low frequency, right? And so this is going to be essentially like the same thing as the LFO that I have up here. Right, so the low frequency oscillator up here, but it's not going to be a smooth jump. It's just going to give us random numbers. It's just going to give us random values, not numbers, sorry. Random values, okay? So let me turn that up a little bit. All right, so we'll just turn it on a little bit, and the level doesn't really matter that much, but as long as it's on. Okay, and then from there, so let me get this so you can see. So from there, this low frequency noise, so it's just gonna be random like voltages, and I'm gonna put that into the input of this thing called sample and hold. Okay, and so what sample and hold does is it basically creates like a rhythmic grid, like da, 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 and it's going to sample the value, whatever this low frequency value is. It's going to sample that, and then we're going to send it up to the filter again, okay? So I'm going to take this out. I'm going to take my old LFO out of the other one, okay? Man, it is hard to breathe in these masks and talk and teach. Like I'm going to pass out any second, just FYI, everyone. Yeah, okay, so yeah, so we're going to take, so it's going to sample that low frequency voltage and then hold it for for like a set amount of time. And we can change the speed of that. And you can see actually this little light flashing here. That's telling you how fast it's like sampling values from this. All right, so it's picking something and holding it until the next sample blinks, and then it's going to and then it's going to choose something else and then send that through. Okay, and so that's going to come out of the output of the sample and hold. Okay. And then once again, we're going to put that into the input. We're going to use that to control the cutoff of the frequency up here. Okay. All right, so I have the volume down right now, but just to review where the direction everything's going. So I have my main, this is my sound, right? This is my original oscillator over here. And this is the sound that we hear going into the filter. And then I'm using this low frequency noise down here, sending into the sample and hold. Sample and hold is going to sample that value, sample that voltage value, and use that to control the cutoff of the filter, right? And so remember here we have our thing going into our original sound going into the filter over here, and then the cutoff is affected by all this that's going on down here. So let's see if it's working. Oh yeah, okay, it is working. That's cute. Okay. All right, this is how robots talk to each other. How computers talk to each other. Yeah. Okay, and so we can change the speed of that by changing. It says down here the sample rate. Okay. Everyone on Link can hear it okay? Yeah, okay. Let's pick that nice groovy value right here, I think. Okay, yeah, that's pretty groovy. Okay, and then we can change, of course we can change our original frequency. Right, so this is our fundamental. And so remember what our filter is doing with the bandpass is just basically just like picking harmonics to play. Okay, picking which parcels it's going to play based on like where the cutoff is. And that's all controlled by this down here. Okay. Oh yeah. Okay. And so this is starting to get cool, and we can do more, but oh sorry, we can do more, but I think that's all we need to do for now. Anyway, and so we can and we can change the amount that it's affected, so we can make this almost like 0, and then it won't do anything. Yeah, it's just barely changing, or we can do like a really wide change by changing that. Yeah, and then we can also control where the center of the frequency is here. Right. And so for example, if I tried to do the same thing with a sine wave, it wouldn't work. Can anyone explain why this wouldn't work with a sine wave? Yeah, Austin, sure. Right, yeah. So Austin said the sine wave doesn't have any of the upper partials, right? And that's what we're isolating. We have our sawtooth wave here that has that has all the partials, and then we are isolating those with our filter, which is like filtering out all the frequencies we don't want. Okay, cool. So that wouldn't work with a sine wave because we don't have any of those partials. It'll work with a triangle wave or a square wave. Let's try it actually. It sounds pretty similar because it has partials too. So, and then let's try it with triangle. Oh, that's nice. That's so cute. Can y'all hear it? Yeah. Okay. Anyway. Cool. So that's how that works. If you ever get a chance to play with one of these, it's a lot of fun. But you do kind of have a chance once again. So I'm gonna exit this. And then, have I been sharing screen? No. Which is good. Okay, cool. Let me get rid of this too. So 218. I'll just show you real quick. Is there anything we need to go over, I wonder? No course in business things, I don't think. Yeah, I think we're good. Okay. Yeah. Oh, yeah. But before I forget, you guys, I'll probably send you an email just to get everyone caught up this weekend because there's people joining the class this week, and maybe some people didn't do the summit for today, hint, hint, or last time I checked anyway. But anyway, so I'm going to just get everyone regrouped and give you an idea of what the game plan is for the next few weeks. Please remember to always check the course schedule for whether or not we're online or in person. Okay, that's, yeah, so I probably won't send emails unless I do like last minute changes or something for that in the future. Right, so just always check that. And it'll pretty much be, it'll be pretty steady, I think. Yeah, I shouldn't change it too much. Okay, so yeah, so let's look at this other thing, this VCV rack. So if you have the chance to download it, you try it out. Maybe if you want to like use it for some things in the future, you don't have to download it because there won't be any assignments with it. But yeah, it's fun to play with, and it'll teach you a lot more than I could teach you. So basically how it works though is very similar. Like you basically just make patch cords yourself. So like all these things in my video, these wires are called patch cords. And so that's how you send signal from place to place. And so right here, this is similar to my two oscillators here, right? This is the same thing. That's what this is. And so I can take the output of that. And see, I have the same thing here. I have sine, triangle, saw, square that I had other places. So I'll just take a sine. And now it'll give you a little wire, and you have to like drag it. So right here's the output. I hope this isn't too loud. Oh, it's not connected to the right audio device anyway. Why didn't it work? Oh, here. Yeah. Okay, so you guys probably can't hear it that well, but let me try to, here, real quick, I'll try to connect it to the Zoom. It might crash Zoom, so goodbye everyone if it crashes. I want to go to, yeah, choose the direct sound driver, and we're going to do Dante transmit. Okay, here we go. Please don't crash. And we're using a sample rate of 48 because that's what Dante likes. Okay. All right, and so everyone take out your earbuds in case it's too loud. Okay. Okay, yeah, I'm just gonna stop that because I can guarantee that that is awful for you all online. Okay, so maybe we won't try that out today. Was that awful for everyone online? I'm sorry. Pretty loud. Nope, Zoom saved us. Okay, good. Okay, Zoom saved you. Good. It wasn't that loud. Okay, good, good. Okay, because it was pretty loud here actually, too. Okay, so I won't connect anything else, but basically that's how it works. So you can try things out, and so this is an oscillator here, and so right down here is an LFO. So like on my module that I was showing you here, you can do both LFOs and like regular sound with the same thing, but here you have to have two different things. If you want to add modules, oh, this is important. So you like right click, and then it gives you like a whole list of things you can add. Okay, and then I'll show you also. Right, so there's all kinds of modules you can play around with. So like here's a scope where you can do something similar to what I was doing in Reaper, where you can like watch the sound. You can see what the sound waves actually look like. Yeah, and so here's the output. You always need one of those. What else do we need? Oh, ADSR. Not ASMR, ADSR is attack, decay, sustain, release, and we'll talk about that one day. But yeah, basically that can shape the sound. And what else can we do? But yeah, there's all kinds of things you can play around with online. If you go to vcvrack.com, vcvrack, yeah, maybe this will just take me right there. On their website, there's a library of modules that you can like. You don't download them, but like you like sign into your account from within the program, and then if you add them, you have to like make an account or whatever. But you add like the quirky modules on here, and then you can when you open it up in the program, those modules will be available whenever you right click here. Right, so like I added this one library here. That's the only thing I've done so far. I just discovered it like trying to get ready for teaching this class online. So yeah, and so I've not really played around with it a lot, but you're welcome to. Okay, all right. So I think that's all we have time for today. So I hope everyone enjoyed this, or if it was useful in some way. Make sure you will actually have to know, so review that. The slides that I had you pull up at the beginning, that just gives you the shape of the four waveforms. Okay, so those are the four waveforms that we used on the modular synth today. I'll go over them again, of course, but you will need to know like what the properties of those are for your little test, that we'll do. I guess it's like the beginning of October or something. But like I'll review everything of that ahead of time, of course. Okay. All right, cool. So thanks everyone. Let me know if you have any questions. Those of you who are online only, and not in Houston, and you don't have a mic, stick around for a second, and we'll discuss what your game plan is. Okay. But other than that, bye everyone. I hope you have a great long weekend. Remember, no class on Monday, of course. Good. Cool. Thanks, guys.